Today we're looking at notes N-1, trig functions where r is not equal to 1. In other words, the radius is not equal to 1 because the points you're going to be given today are not on the unit circle. Therefore, the radius will not be 1. So we're either talking about points that don't go all the way to 1 unit or points that go further than 1 unit. The radius is either smaller or larger than 1. Okay, so what I want you to think about, just like we did with the unit circle, is the triangles, the right triangles that are going to be created here. And now, again, since we're not talking about the unit circle, the hypotenuse, or the r, the radius, is not going to be 1. So since we don't know what that r is going to be, we're going to have to utilize Pythagorean theorem to find out what it is. So recall, given a right triangle, Pythagorean theorem states a squared plus b squared, or a squared plus b squared, one of the legs, the a and the b are the legs, equals c squared. Okay, and that tells you the hypotenuse. So here we're just going to basically use Pythagorean theorem, but with different variables. So, of course, this flat leg is the x, this vertical leg is the y. So, in other words, x squared plus y squared equals r squared. Notice I've put the square root on top because I want to find out what r is. So square root both the left and the right side. So you get the square root of x squared plus y squared equals the square root of r squared, which is absolute value of r. To remove the absolute value, you have the plus or minus over here on the radical, so then we just have r. But remember that r, the radius, that's distance. X and y can be negative. X and y can be negative because they're talking about position on a graph. Like you can have a negative x value, you can have a negative y value, but you can't have a negative distance. So therefore, r will never be negative, so r is positive. So our formula will just utilize the positive version. So our formula for r, or radius for today with the triangles we're dealing with within circles, will be r equals the square root of x squared plus y squared. All right, so now let's use this knowledge to do some examples. Find all 6 trig functions. So what's in black is what's been given. So on number 1, if this is theta, and this is the point 4, 3, 4, 3, we want to find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay, so we have to think about a couple of things. So I drew the triangle over here so you could see. If this is theta, our x value is 4, correct? Our horizontal position here is 4. Our vertical is 3, so this is the triangle that's created. We want to find the r, the radius of a circle that's been created here. So we're going to use our formula for r. So square root of x squared, 4 squared, here's our formula, plus y squared, so 3 squared. So of course we're going to do what's inside the radical first. So 16 plus 9. 16 plus 9 is 25, so square root of 25, which means r is 5. So we'll fill this in, 5. So then for sine, remember, we're thinking SOHCAHTOA. SOHCAHTOA. So for sine, we're talking opposite over hypotenuse. Okay, so opposite of the theta is 3 over hypotenuse is 5. So sine of theta equals 3/5. Cosine of theta, adjacent over hypotenuse. Adjacent would be 4 over 5. Remember, we can't just say that sine and cosine are the x values or the y, well, x values here, y values here today, because again, that r is not 1. So before, we could just say it was the x or the y because the r is 1, everything was over 1, but now we cannot. Okay, so tangent, remember, is opposite over adjacent. So opposite over adjacent, so 3/4. Cosecant, so I have lined these up with their reciprocal pairs. So cosecant is the reciprocal of sine, so this would just be 5/3. Secant is the reciprocal of cosine, so this would be 5/4. And then cotangent is the reciprocal of tangent, so this would just be 4/3. So we're done with that example. So look at example number 2. So in example number 2, you were given the triangle in black here. So our horizontal distance, or our x value, -4, okay, and then our vertical, if we're thinking on the grid, would be +1 if this was the origin. So then this is our theta, this angle is our theta. We want to find r first. So remember, our formula is the square root of x squared plus y squared. Okay, so then we have r equals -4 squared is 16, 1 squared is 1, so 16 plus 1 is 17, so the square root of 17, and that cannot be simplified, unfortunately. So we know we would have a hypotenuse of square root of 17. So again, sine is opposite over hypotenuse. So if this is theta, we're talking opposite over hypotenuse, so 1 over square root of 17. And ding, 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 you're hearing red flashing lights go off in your head because you cannot keep that radical in the denominator. So rationalize the denominator, and we would get square root of 17 over 17 for the sine. For the cosine, adjacent over hypotenuse, so -4 over square root of 17. And again, you must rationalize the denominator, so square root of 17, square root of 17, and then you would get -4 square root of 17 over 17. This cannot be simplified, so we're done there. Tangent, remember, is opposite over adjacent. So we've got opposite over adjacent. So this would be 1 over -4. And personally, -1/4 is what we typically see and what I prefer. Okay, so then cosecant. Cosecant is the reciprocal of sine. I don't want to reciprocate this. That would put a radical in the denominator. Let's take our original before we rationalized. Reciprocate this original, and we just get square root of 17. Reciprocate similarly, reciprocate this, and you'd get square root of 17 over -4. And again, you know I want that negative on top, so square root of negative square root of 17 over 4. Okay, and then here, reciprocate this, and you would just get -4. So we're done with example 2. Moving along to example 3. Okay, so now you've just been given a point. The point -4, 10. So I have gone ahead, this was not given, this was the only thing that's given in black. I've gone ahead and I've drawn the triangle here. I know it's not proportional, but you know, did my best. So -4 is our x, so horizontal, 10 is our y, so vertical. Here's our theta. I didn't draw in the theta like I should have. Okay, and so then let's find our h, our hypotenuse, really our r. So square root of -4 squared plus 10 squared. So -4 squared is 16. 10 squared is 100, so 116. So square root of 116. 116 does break up. 116 is 4 times 29. 4, as you know, is a perfect square. That breaks up into 2 and 2. Okay, so r equals 2 square root of 29. Okay, that's as pretty as that gets, unfortunately. So then, I write this here, 2, what have I been writing? Oh, 2 square root of 29 here. So then sine, opposite over hypotenuse, so 10 over 2 square root 29. So then simplify this a tad, and you know you have to rationalize. So I will just simplify first. So this would be 5 over square root 29. Then I will rationalize square root of 29, square root of 29. And then this equals 5 square root of 29 over 29. And that cannot clean up anymore. Okay, so next cosine is our adjacent over hypotenuse. So we would have negative 4 over 2 square root 29. And again, this does simplify here. So you would have negative 2 over square root 29. And then you must rationalize, so times square root 29 times square root 29. So you would have negative 2 square root 29 over 29. All right, so then tangent, okay, tangent, opposite over adjacent. This one ends up being not too bad. So 10 over negative 4. And of course, it not only simplifies, but you want to bring that negative to the top, so negative 5 halves. Okay, so remember, cosecant, reciprocal of sine. I want to reciprocate from here, not from here, because I don't want a radical in the denominator. So this would just be square root of 29 over 5. This would just be, I'm going to bring the negative to the top, square root of 29 over 2, and then cotangent would just be negative 2/5. All right, so now we're done with that example. Last thing, part 2. Part 2, which quadrant, similar to notes B-1, where we talked about when x and y values are positive or negative, etc., except now we're dealing with the trig functions. So I've written a grid here that has the x and y values in positive or negative, as you already know. Okay, so if I want, number 1, sine of theta to be greater than 0 and cosine of theta to be less than 0, first thing you want to think about is sine. Sine is, if we're just talking about theta, we can think back to the unit circle. Okay, so sine means our y values. So y is positive, in other words. Greater than 0 means positive. Cosine of theta is less than 0, so this means x is negative. Okay, so let's draw our grid. Let's talk. Where is y positive? Well, this quadrant and this quadrant. Where is x negative? This quadrant and this quadrant. Where do we have overlap? What quadrant is this? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this would be quadrant 2. Okay, next example. Cosecant of theta is greater than 0. Y'all remember, cosecant is 1 over sine. So 1 over sine is greater than 0. Y'all, this 1 is positive. So basically, what this means here is that sine, we don't care about the 1 because the 1 isn't going to change anything. Whatever this sign is going to be, it's going to be based on this, not the numerator, because the numerator is positive 1. So this basically means that sine is positive. In other words, sine of theta is greater than 0, which really means y is positive. Okay, for tangent, remember tangent, we're talking y over x is negative. Okay, so let's talk about these two things. So here, y is positive, that's easy. Okay, that's easy. Y over x is negative. Remember, how can a number over a number be negative? It can only be if one or the other of them is negative, not both. So the only quadrants that one or the other is negative would be quadrant 2 and quadrant 4. Because one is negative, one is positive, one is positive, one is negative. So this quadrant and this quadrant. And the only place I have overlap is here. So also this answer is quadrant 2.